Hello everybody and welcome to Joy of Calculus, Episode 1. Today's subject, net change. First thing that I want you guys to know about integrals is that I know that we talked about them as measuring area, but something that's a little more specific is that integrals measure accumulation, which area is a form. This is actually going to be pretty useful to us today during this lesson for net change. The other thing is that displacement is something I need you guys to know as well. Now displacement is defined as that integral up there, and that's the first thing that we're going to find here. So take a look at this velocity, and what we're going to do is factor this, and use that factorization to graph it. You can see we have a 0 at -1, and we have a 0 at +6. I put 2 tick marks there out to 8. It is a parabola going up, and as you can see here, we have in that parabola, which, by the way, this parabola is velocity, so always remember that as you're going through this. During that interval from 0 to 6, the velocity is negative. Now, if this is a particle that's traveling on a straight line, the velocity being negative means that that particle during this time is moving towards the left with left distance. Now, for the velocity that's positive from 6 to 8, this implies that the particle is moving towards the right. This will be important when we get to the second part of this problem, which has to do with total distance. Now in part A, what I want us to do first is find the total displacement of the particle from time 0 to time 8. And this is a pretty simple problem. All we're going to do is pretty much use that definition right up in that upper left-hand corner for displacement. So we're going to set up an integral. Integral is going to go from 0 to 8, as defined in the problem. We'll plug in the velocity function there. Always include that dt, gotta remember it. And let's antiderive. Fundamental theorem, here we go. We're going to let it go from 0 to 8. And let's plug in these numbers and let's see what we get. Get 1/3. That little clip there was me actually looking up what 8 cubed is. You can see what the rest of the numbers are right here. And it's pretty much just calculating. Remember that when we plug in the 0 for a polynomial, it's just 0. And this actually ends up being -37.3 repeating. So that was just a little simple calculation. The important thing to know is what it means. Due to the fact that this particle is moving to the left first because of the negative velocity, then moving towards the right, some of that distance is actually going to cancel itself out, which means that displacement, the distance the particle is from the start, is actually to the left of its starting point. So if the particle started at position 0, its new ending position would be -37.3 repeating. It's a pretty important concept, so try to remember that. Part B, let's find the total distance traveled by the particle over this time interval, which is a different calculation than displacement. We have to be a little more careful about how we think about this. Now, for the total distance traveled, we're going to consider one thing first. That is the time at which the particle changes direction. This is important because the left distance is counted as negative, usually because of negative area, and the right distance is counted as positive. We want to separate those two so that we can count both of them as positive and add them together. So this distance here, we'll first consider the integral from 0 to 6. Now as I'm writing this, take a look up in the graph there. This integral from 0 to 6 is very clearly below the x-axis and therefore negative. We'll deal with that in a second though. Next integral will go from 6 to 8. And this is our positive distance. This is our rightward distance. Now, we need to find a way to reconcile the fact that due to that the left integral is negative and the right integral is positive, we want to make them both positive, therefore adding to each other. Rather than the left distance sort of canceling the right distance out and then some, we're just going to take the absolute value of the entire left distance. Basically just make the whole thing positive. That's all I'm doing there. We want the left distance to be counted as positive distance for the total distance calculation. So we do that. And we pretty much just antiderive from there and plug them in. You could also use your calculator, mind you. That's what I do here. We get the absolute value of -54. By the way, that means that the particle moved 54 units to the left, and the other one, particle moved 16.6 repeating units to the right. When we add them together, without regard to direction, we get a total distance of 70.6 repeating. Last thing before I leave you guys for this lesson, there will be a few problems in the assignment that ask you to find the total amount of accumulation of a rate of change function over a certain interval. Those are pretty easy actually once you recognize the pattern. All I want you to know is that you set up an integral, putting the rate of change function inside of it. You let the integral go from the starting point to the ending point, and then you just put it into your calculator, use the fundamental theorem, and see what you get. What's the total accumulation? Alright, that's pretty much it. Thanks guys. Have a good night.